Yes, guys. So we are doing question number 5th here. Okay, question number 5. What does it say? Now, in question number 5 or 5th question, what does it say? It says that prove that the area bounded by the hyperbola, this we are continuing, x square upon a square minus y square upon b square equal to 1. This is the hyperbola given. Okay, the x-axis and the ordinate. This is the x-axis and the ordinate. From x equal to a, we have taken to p, a cos hyperbolic theta, b sin hyperbolic theta is 1.4. This we have to prove that this area between the x-axis, the ordinate from a, x equal to a2, x equal to a cos hyperbolic theta. This means from this point to this point. Between the hyperbola this and this ordinate from a to a cos hyperbolic theta and this. Okay, x-axis. So that is given to us. So this we have to prove that the area, total area, is found out to be 1.4 AB into sine hyperbolic 2 theta minus 2 theta. Okay, this we have to prove here. So everything is given to us. That this is the hyperbola given. Okay, now I have drawn this hyperbola, and what are the points here? This is minus a0 and this is a0. So hyperbola, okay, is symmetric to the x-axis and y-axis both, because x and y both are even problem. This is in curve tracing we have drawn. So this is kind of hyperbola is there. This we know that it is a standard form of the hyperbola, and hyperbola is of this kind. Now this meets the x-axis at a0 and minus a0. Why? If I put y0, then this is obtained. So let me solve this. We have to prove that the area between this. So let me find y. So y square upon b square is equal to, this is x square upon a square minus 1, or this is nothing but x square minus a square upon a square. This is y square upon b square. Or further, if I solve it, y square is equal to, this is b square upon a square within bracket x square minus a square. What is the value of y here? So y is equal to b upon a square root x square minus a. We have to take the positive value. This is the value of y. Okay, so what is the area of this hyperbola? I mean, between the hyperbolic, this arc of the hyperbola, x-axis, and the ordinate a2, a cos hyperbolic theta. These are limits given to us. What the area here? Area, let me find out. So area or required area, let me take. So required area of the curve bounded by the hyperbola of the hyperbola. Let me take hyperbola from x equal to a2. This is x equal to a here, because the hyperbola meets the x-axis at a0, y0, or sorry, a0 minus a0. Why? Because if I put y0 on the axis of x, so then we will obtain x square equal to a square, or x equal to plus minus a. So minus a0 and plus a0, these are the 2 points on the axis of x where the hyperbola meets the x-axis. This we know about. Therefore, y equal to this value. What is the area from this point to this point? Okay, and this hyperbola. We can find out this area. Let me find out. Therefore, the required area of the hyperbola, okay, from x equal to a2, x equal to a cos hyperbolic theta, is equal to x equal to here a2, a cos hyperbolic theta, y dx. This is the limits we have substituted here. This is just one, okay, only between this and that. Okay, so we are not to find out twice for this and that. It says only between this ordinate to this ordinate. Value of ordinate is x equal to a2, x equal to a. This is x coordinate of p. Okay, up to p. So p is having x coordinate as a cos hyperbolic theta, a cos hyperbolic theta. Okay, so let me substitute the value here of x. X equal to a2, x equal to a cos hyperbolic theta, y is this value, this is b upon a under root x square minus a square into dx. Now the curve is turned into x coordinate or x dx. Okay, so in this way we can integrate this now. Let me integrate this. So integrating this value, let me find out. Or if I substitute y equal to 0, that we have already done. So the curve meets that we have the curve meets the x-axis at minus a0. This is in and a0 y at y equal to 0. So this x coordinate we have calculated from the given curve. We know this is the hyperbola. Now we have to calculate this question. Therefore, the required area, okay, of the bounded region between the hyperbola, the x-axis and the ordinates x equal to a cos hyperbolic theta. Simple. Is given by this. This we are calculating. Let me take v upon a out of the integration sign. Okay. Now what is the integration of this? This is x square minus a square. So integration of this will be x square upon 2 under root. Sorry, this is x upon 2. I'm sorry, not x square, but 1.2 into x. Sorry, x square minus a square. This is minus sign 1 upon 2 a square. Okay, into cos hyperbolic inverse. This is hyperbolic inverse x upon a. Limits a to a cos hyperbolic theta. Okay, so this is the formula here. In case of a square minus x square, then it is sine inverse, not cos hyperbolic. This is x square minus a square. This is in cos hyperbolic inverse x upon a. Okay, this is x upon 2 here, or 1.2 into x under root this. Now let me substitute the limits here. Okay, so putting the limits. Finally, what is the area? Let me calculate this. Therefore, this is equal to area is equal to, or required area is equal to b upon a. 1.2, let me take common. It will come out as 1 and a square. Okay, a square is not common yet, but let me. Okay, 1.2 is common. Now putting a cos hyperbolic theta. This is x in place of x. We will have a cos hyperbolic theta under root. It will be in place of x. It is a square cos hyperbolic square theta minus a square because 1.2 I have taken outside. This is a square into cos hyperbolic inverse x upon a means a cancelled out, and this is cos hyperbolic theta. Okay, this is one value with minus sign. If I put the a limit, then first part is 0 because a square minus a square under the square root is 0. And this is cos hyperbolic inverse a upon a is 1. Cos hyperbolic inverse 1 is 0. This is also 0. So in second case, a, when we substitute, both the terms will be 0. Try to understand. Why? Because if I put a in place of x, so this is a square minus a square at the lower limit, minus sign, with minus sign. We have to put minus sign here, but it will be 0. First step is 0. Second step is also 0. This is plus sign, but it will also be 0. Why? Because cos hyperbolic inverse, this is 1. A upon a means 1. Cos hyperbolic inverse 1 is for 0. This is 0. This is also 0. Okay, so solving only these two values, what it comes out to be, let me check it. So it will give us b upon twice a and a square, because a into a, let me take outside, which is 1.2 ab Okay, 1.2 AB. This is within bracket. It is cos hyperbolic theta into, from this it will come out as sine hyperbolic theta. Why? Because cos hyperbolic theta minus 1 is sine hyperbolic theta. Sine hyperbolic is square theta, but is square root and square cancelled out. So this is this value. Okay, minus a square we have taken outside. This is only cos hyperbolic theta. That means only theta. Cos hyperbolic inverse cos hyperbolic theta. That means only theta. This value is only theta. Okay, only theta here. This is theta. Now let me further solve it. This is b ab, sorry, this is 1a cancel out, ab upon 2. Now cos hyperbolic theta, if I multiply this by 2, let me multiply this by 2 twice and divide by 2, no problem. It will be sine hyperbolic theta into cos hyperbolic theta divided by 2, no problem. This is minus theta. What does it say? It is AB upon 2. If I take 2 outside, it is 1.4 here. It will take 1.2. Now 2 sine theta cos theta is sine hyperbolic 2 theta. Sine hyperbolic 2 theta. And this is LCM 2 theta. Because 2 we have taken outside. So this is nothing but 1.4 AB. This is 2 to the 4 here. Sine hyperbolic 2 theta minus 2 theta. Is it the same answer? Okay, this is 1.4 AB sine hyperbolic 2 theta minus 2 theta. Hence, this is the answer here. Okay, this is question number 5. So, fifth question we have done. Same answer is obtained. This is the answer here. Try to understand. This is between x equal to a to x equal to at end point x. A is x coordinate is a cos hyperbolic theta. Simple. This area we had to calculate. This was the required area. Okay, so hence the answer. Same answer is obtained. So this is question number 5. Let me take next question. What does question number 6 say? Let me check it. Okay, so question number 6. Now question number 6 is of what kind? This is here of the loop. Sorry. Okay. Now question number 6 here. Find the area lying between the cardioid r equal to a 1 minus cos theta and its double tangent. Okay. And its double tangent. Let me find out 6th question. Question number 6 here. It says a cardioid r equal to a into 1 minus cos theta. This is the cardioid. The cardioid. This we have traced like this. Here, let me take a bigger one. Okay, this is the cardioid here. I'm sorry, I've taken not of same type. Okay, so this is the cardioid here. No problem. Cardioid here. This is O point. This is X, or this is initial line. Okay, x-axis, x axis, y and y dash axis. Now, what is the point here? It says that this is the cardioid and the tangents of this cardioid. So there are two tangents here. A tangent at this point and tangent at this point. There are two tangents here on this cardioid. So these are the two tangents. Okay, so we have to find out area. What is the area here? So this is the area. Let me take here any point. That this is A point, this is B point, this is B dash point. No problem. Now what is the angle? Let me just talk about. Okay, so the angle, let me take this angle, the vectorial angle of this B is r theta, and this is theta here. Let me take this is the angle theta. It is actually this tangent is making with the initial line angle 90 degree. This is, let me take phi here or theta here. Let me take psi here, and this is the angle phi. Let me take. Okay, so we are taking three angles here. What is the angles? Now this is 90 degree undoubtedly. Psi angle is 90 degree. So theta plus phi is equal to. So we have to find out what are the vectorial angle for this B. What is the vectorial angle? Theta we have to find out. So what is theta? First thing we have to find out. Theta is here vectorial angle. Is the vectorial angle for B. For B vectorial angle. This is r theta. Let me take. Okay, so for r theta, what is the value of r? What is the value of theta? That we have to find out. So theta we have to find out. Theta is this angle. Okay, here I have taken here angle B O A equal to theta. Okay, and angle OBA I have taken, let me take phi. So this implies that angle theta plus phi is equal to pi by 2, which is equal to psi here. This is the exterior angle psi, and here psi angle is BA. Let me take X here, or let me take here ABC, no problem. ABC. So angle here, angle BAC is equal to psi equal to 90 degree, or pi by 2 here. This is pi by 2, or equal to pi by 2. Simple. So psi angle is pi by 2. So exterior angle is equal to sum of the two opposite interior angles. So phi, this phi angle we have taken OBA. This phi angle we have taken. Okay, so for that actually we have to find out what the angle from this point to this point, theta value. What is the value of theta here from this point to this point? So area, we have to find out area between, okay, this total area here, cardioid, and between this point. So area of the triangle minus area under the cardioid from this point to this. Limits are same. Okay, we have to find out this length, area of the triangle, half base into height, no problem. We take OA into OAB, okay, into half area of the triangle minus area of the cardioid. Cardioid area is let me take OABO, this. Okay, and area of the triangle is OBA. Triangle area is half base into OA into AB. That's the area of the triangle. So the difference between, but twice of that, because same area is below this, between the cardioid and the two tangents. Okay, so this is the point we have taken. So this means theta plus phi is equal to pi by 2. But we know that this angle phi, but we know solution we are finding out. Solution here. So theta plus phi is equal to this. We know from the differential tangents and normals. Differential calculus, we know tangents and normals. Tangents and normals. The tan psi is equal to r into d theta upon dr. R into d theta upon dr. This is equal to r into 1 upon dr d theta, or r upon, this is r upon dr d theta. What is the value of dr d theta? That will be calculated from here, and r is that value. Therefore, tan phi, this phi, tan phi angle made by the tangent with the, okay, at the point of contact with the curve. Okay, so this tan phi is equal to R here is this A into, this is first equation, let me take A into 1 minus cos theta, right? This is then phi equal to R upon dr d theta. This we know from trigonometry, I mean this from differential calculus. R into d theta upon dr. Okay, from polar coordinates we know this, polar equations. So this we calculated. This divided by dr d theta. Dr d theta is differentiation of this first equation, and dr d theta, let me find out here. Dr d theta is equal to A is 0, A into minus cos theta, that means minus sin theta, minus plus A sin theta. This is nothing but A sin theta. So differentiation of cos theta is minus sin theta. Differentiation. So minus plus here, it is A sin theta. So dr d theta equal to A sin theta. Let me put here A sin theta. A cancelled out. Now 1 minus cos theta is nothing but 2 sin square 1 upon 2 theta divided by sin theta can be written as 2 sin theta by 2 into cos theta by 2, or 1 upon 2 theta. 2 cancel out. 1 sin half cancel out. This is nothing but tan theta by 2. Good. Sin theta by 2 upon cos theta by 2. 1 sin theta by 2 is left over. Now since we know sin 2 theta is equal to 2 sin theta into cos theta. If it is single angle sin theta, it will be then 2 sin theta by 2 into cos theta by 2. So we have substituted in place of sin theta here 2 sin theta by 2 into cos theta by 2. While 1 minus cos theta is 2 sin square theta by 2. Why? Because cos 2 theta is equal to 1 minus 2 sin square theta. From this 2 sin square theta equal to 1 minus cos theta. Therefore 2 sin square theta equal to 1 minus cos 2 theta. But this is 1 minus cos theta, so it will be 2 sin square theta by 2. This is this. From trigonometric identity we have taken this. What we want to find out? So theta and phi relationship. So here phi is equal to 1.2 theta. This implies that because tan phi is equal to tan theta by 2. Tan phi we were calculating is equal to tan theta by 2. That means phi is equal to theta by 2. If I substitute here phi theta by 2, what do we get here? So therefore, the relation between theta and phi we have obtained. The value of phi here. So theta plus here phi is theta by 2. 1.2 theta is equal to pi by 2. Okay, so this is 3 by 2 theta is equal to pi by 2. 2 to cancel out. So theta is equal to pi by 3. Okay, so what are the limits here? From this point, here theta is 0. Theta equal to 0 to this point. This theta is here pi by 3. So theta we have obtained here pi by 3, this angle. Okay, so limits for theta we have taken this pi by 2. If I put pi by 3 in first equation, so what is r here? Therefore r is equal to, r can also be calculated, r is equal to, because we have to find out what is OB. So theta is, let me write here, theta is equal to 3 by 1 by pi by 3, sorry. So what we obtain here, theta is equal to 1.3 pi. Substituting in this implies that r is equal to a into 1 minus cos pi by 3. This from first equation. From first we have substituted the value of theta, which is pi by 3 here we have obtained. That means this is a into 1 minus 1.2, because cos pi by 3 is 1.2. 1 minus 1.2 is half. That means a upon 2. So r is equal to a upon 2. A is a upon 2. Sorry, r is a upon 2. So r is obtained and theta is also obtained. Let me now find out that what is the area, required area. Therefore area, here we have obtained r is equal to 1.2a. Theta is equal to pi by 3. These two things we have calculated. Note, this we have calculated here. Therefore between, it says between the tangents and this. So this is the area. What is this area? Between the tangents, right, and the curve here. So if I find out this total area of the triangle and this ordinate, sorry, this what is the cardioid, and between the cardioid. So area between the cardioid, this we have to find out twice of this area. What is the area between these two? So triangle area minus area of the cardioid. That is the area between the tangents and this twice of that area. You will calculate. So that area we will calculate then. So twice of that area will give us total area between these two. Okay, so area required, let me take. So what is the area here between the triangle and the cardioid? This is in between area. You have to find out, and the area lying between the cardioid, okay, are equal to A into this and its double tangents. And its double tangent. This is the shaded portion here which we have to find out. What is that? Area and cardioid is going away. That means from this 0 to theta, because here B is theta. So cardioid is having 0 to pi by 3 angle, undoubtedly 0 to pi by 3 limits are, and R we will take this area between the triangle and the cardioid. So this cardioid and tangents and cardioid, we have to find out the area between. Okay, let me subtract this area, which is triangle minus area of the cardioid, because this cardioid is between angle 0 to pi by 3. This area is to be subtracted. The required area is, let me find out. The required area between the cardioid, it says between the cardioid and its double tangents, this shaded portion, twice of the shaded portion, that area. This is equal to twice. Let me find out what is that area. This is twice of area OABO. This is the area, which is equal to twice of area of triangle, OAB minus area OB, or let me take here C point, OCBO. Okay, that means we have to find out this twice. Area of the triangle is half. This is, let me take OA into OAB, into AB, OA into AB, or BA, OA into AB minus area of OCBA. This is half of limits between 0 to pi by 3 r square d theta. This we will substitute here. R is that value that we have to substitute here. Okay, so and here also for the area of the triangle, and these limits we have to find out, because area of the triangle is simple. That area we will calculate, and then what is that area? Let me just calculate that. Okay, so total area of this cardioid will be twice half. OA is what? OA is base here. OB into, this is OB cos 60 degree. Pi by 3 is OA pi by 3 into OB into sine, because this is perpendicular. OB into sine 60 degree or pi by 3 angle minus sine half 0 to pi by 3. This is r square. R square is that value, that means a square into 1 minus cos theta whole square into d theta. Okay, so this we have to calculate now. Now let me substitute the value of r. OB is r here, which is a upon 2. This is twice a upon 2, a upon 2. This is 1.2 into a upon 2. Cos pi by 3 is 1.2 into, sorry, again OB is 1.a by 2. Sin pi by 3 is root 3 by 2. Sin 60 degree is root 3 by 2 minus sin 1.2. Now this, okay, so if I just open this, okay, let me open this then. So this is a square. Let me take outside because a square is coming out. But let me put here still a square is there. Okay, no problem. It will give us 0 to pi by 3. Let me open this. This is 1 minus 2 cos theta plus cos square theta d theta. Okay, so this is, if I multiply by 2 inside, and let me take a square common outside. First 1 2 is cancelled out. Here it will be 2 2 2 4 root 3 by 16. This is root 3 by 16 minus sin. This 2 2 cancel out. This is only this value. So what is that? So still let me solve it. 0 to pi by 3. 1 minus, if I put value of cos square theta, that will be 1 plus cos 2 theta upon 2 into d theta. Okay, so this is the value. Let me further solve it. Now let me rub this because twice of this whole area that we will calculate then. Let me solve it now. I have removed the curve here, but the curve is of that kind. So finally, what do we get? This is equal to a square into root 3 by 16 minus sin. Okay, this is 0 to pi by 3. 1.2 plus 1, that means 3 by 2 minus 2 cos theta plus second is 1.